Welcome to BCO1436. My name is Lee Dilworth, Principal Engineer for VMware, based out of EMEA, hence my accent. So I apologize for that. That's usually the one bit of negative feedback I always get from the audiences is speaker had an accent. There's not much I can do about that. We all tend to have accents, so mine's just a weird British accent, so I'll try and speak clearly. I'm joined this morning by Rahul Ravalur, who'll introduce himself in a second. We're going to talk to you for about an hour on vSphere Replication and some of the new enhancements that we've put into 5.1. One thing to say about the session, we do want interaction in terms of questions, but if you can try and keep those towards the end, that would be great. What tends to happen with this kind of material is the first part of the content generates a lot of questions in your heads, which is actually covered in the second half of the content. So what happened on Monday or Tuesday is all of those questions came out, and we kind of had to answer things that were on the later slides. So probably makes more sense to keep the questions till the end, and hopefully we'll answer the questions you're thinking about as we're going through the deck. So without further ado, I'm going to let Rahul drive the first part of the session, and then I'll do the second part and the close. Okay, over to you, Rahul.
All right, thank you. Thanks, Lee. Everyone in the back hear me okay? All right. Yeah. Okay, good. Welcome to VMworld. Hopefully you're having a good show. Just to quickly introduce myself, I'm the Group Product Manager for Site Recovery Manager at vSphere Replication. And we're very excited to actually talk about some of the announcements we made. As Lee just said, please do keep this interactive. I know it's a large audience, and we'll like to get your questions, and we will get all your questions. Even if we run out of time, we're happy to hang out later and take your questions as well. Feel free to let others know as well. We'll make the slides available later. One thing I should say is we will actually, as we go through some of the features, we may speak about some of the future-looking content, which is not going to be available with 5.1. And that's a standard disclaimer. Please keep in mind there's no commitments as far as the roadmap is concerned, right? Okay, we talked about this. Do interact. So vSphere Replication. This is something we introduced with 5.0, with SRM 5.0. How many of you in the audience have used vSphere Replication? A show of hands. Okay, about 15 or so. Okay, that's good. So just for the benefit of everyone else, let's do a quick recap. vSphere Replication is asynchronous replication that's done at the vSphere layer. So we actually made this enhancement with 5.0, vSphere 5.0. It's built into the vSphere. When you get ESX 5.0, there is an agent in the kernel that allows you to essentially split the I/O. We'll talk about the details, how that works. But the idea is that it's all actually done at the virtual machine level, right? Replication is an attribute of the virtual machine. You go in and set how replications should be done. And because we do it at the hypervisor level, you're completely agnostic in terms of what storage there is. So you could have brand A of storage on site A and another kind of storage on site B, and you'd be able to replicate just fine, right? Because as long as you have vSphere 5 on both sides. It's completely heterogeneous. Also, the other aspect is we've actually done a lot of work, and Lee is actually going into details about this in terms of the protocol, to make this efficient in terms of how we replicate from site to site. And also, we try to minimize the impact on the virtual machines itself in terms of how the interaction with the virtual machine is. Now, how would you actually use it? You would, in the past, you needed to buy SRM 5.0. You buy SRM 5.0, and that actually gave you a virtual appliance to deploy, and we could actually use vSphere Replication with that. And the configuration and the entire setup was driven via the site recovery manager workflows. The one thing I should point out is we do have customers who are actually doing DR to the cloud, and we actually partner with service providers at Site Recovery Manager. And vSphere Replication is the basis for that. So what we see customers doing is they have some kind of storage at their site, and the service provider has a different kind of storage, and vSphere Replication is the basis via which you replicate because it's heterogeneous in nature, right? So you can actually go from customer premise to cloud. That's what we call the cloud DR offerings. And that's the basis most of our service providers are using to onboard customers into the cloud. So what has changed? With vSphere 5.1, vSphere Replication actually becomes something available with Essentials Plus and higher. So if you have vSphere Essentials Plus and higher, With 5.1, you have vSphere Replication. Just like VMware HA or other features that are bundled with vSphere, vSphere Replication is a feature we've actually made that available, and we'll talk about why and what are the types of use cases that you can use this for. It is actually still the same heterogeneous replication. It is per VM replication out of the box. It's actually a very simple setup. We'll kind of go into how the setup is. Very simple virtual appliance that you set up and configure, and you can actually deploy it. And once you do that, you can actually go replicate from site to site. So let's just rehash here. Does this mean you can use vSphere Replication without Site Recovery Manager? The answer is yes. Can you actually replicate and recover per virtual machine? Can you actually use this with vSphere Essentials Plus? Can I actually use this within a single vCenter? And this is actually a change from earlier, because there are some use cases where you might want to be replicating within a single vCenter. We'll actually go into more details over here as well. And once you actually start using it, you can actually go ahead and start using Site Recovery Manager as well. And the answer to this is yes for all of these, right? And we'll go into each of these, how this is going to work. So how many of you are Essentials Plus and higher? Show of hands. Great. All of you have vSphere Replication, right? So just keep that in mind, that this is something you have. It's available for you as soon as we launch vSphere 5.1. Please do give it a try and let us know how this works. So let's look at some of the use cases. Let's back up and say, what are the types of things you want to do with replication, right? One is the same way as I was using storage replication. I want to get my bits from my data from one site to another. I just want to replicate it. It may not be a large environment. And once I replicate it, I have a manual recovery process in terms of runbook. The second is the remote office, branch office. So we actually, Lee was just telling me about this customer in South Africa who actually has a lot of these different stations, and they can want to actually replicate from site into their central office. And again, typically you have tier 1 storage that's running in your main data center, and you have a tier 2 storage that's running in your branch offices. This is actually, vSphere Replication is ideally suited for it, because now you can actually start replicating in from these different remote offices into your branch offices as well. Remote offices into your central office here. The third one is your local recovery solution. So this is about, I'm in a single site. I actually want to just make sure that I have availability. So in case I lose my data store in one pod, I should be able to actually recover it in another pod as well, right? So that's my local recovery solution. I can just replicate from one site to the other. The fourth one rather is about one vCenter managing multiple sites, but I actually want one site to be a recovery for the other, right? So you have one vCenter that's managing multiple sites. I'm actually replicating between two different sites as well. You can do that too. And the last one actually is an interesting one, which is around data center migration and collapse. So a lot of times you find you have other data centers you want to actually consolidate into a single data center. We just had a large customer who actually did this with vSphere Replication with about 400 VMs, large financial customer. So they use vSphere Replication to go from one data center to the other with different storage. Once they actually migrated everything into a single data center, then use Site Recovery Manager to protect that data center. So they have a DR plan over there. So the heterogeneous nature and the per VM nature makes this really, really simple. One other point I should mention here is that because it's per VM in nature, what happens is typically when you're using array-based replication, you replicate your entire LUN, right? You replicate your entire LUN from one site to the other. And what happens is when you start adding in additional applications that you want to replicate, you now need to start reorganizing your storage. Does this go on replicated storage versus not? And that actually adds a lot of overhead in terms of how you're organizing your storage and storage management. And that's where vSphere Replication makes this easy, because it's per VM. It doesn't matter where your VM DKs are, what data stores. You can just pick what applications, as your application teams or you are deciding which applications need to be replicated from site to site, that actually you don't need to worry about how your storage is organized underneath, right? That actually makes this a lot easier. So these are all the use cases that we will actually go into, and Lee has some architectural diagrams as well to talk about how we can actually address this with vSphere Replication going forward. So how do you use this? As I was saying, it's a really simple process. So you actually have a virtual appliance. You actually go to VMware.com. You actually download this virtual appliance. you will actually install this virtual appliance using, it's an OVA, so in the import OVA, or import OVF, you actually go through a simple installation process, pair it to a vCenter server, and then you configure a VM for application. And in terms of configuring a single VM for application, you're setting an RPO. An RPO is the amount of data loss you're willing to tolerate, right? The recovery point objective. So each VM can actually have an individual RPO set at that level. So you could say my database VM needs to have a 15-minute RPO, and maybe my other applications like a file server, I'm okay with a 12-hour RPO. You can even choose to ignore disks on a per virtual machine. You could have a virtual machine that has, say, log files that you don't want to replicate from site to site because that's actually generating a lot of traffic. So you could choose to actually ignore that log file, that disk as well. For each virtual machine, you also specify what is the target data store, what is the target folder, and you can actually, once you do that, you're done. Now that actually configures the VM for application. We'll talk about how the architecture works in just a minute. In terms of how this looks, I don't know if you've seen the vSphere web client. There's something we actually launched with vSphere 5. We actually enhanced it, but that's where all our products are plugging in now. So vSphere Replication, actually, when you install this OVA, it installs a vSphere web client plugin as well. And that actually manifests itself on the same VM summary page. So actually, when I look at a VM summary, I can see the replication status. I can go to another page which shows me the replication status for all the virtual machines, then going and outgoing replication at the vCenter level. I can also right-click a VM and then say, choose to configure replication for it right from the VM inventory page itself, right? So it's all integrated into the same vSphere web client, and you don't need to hop between different consoles. And that actually really makes this simple to manage. One other thing I should mention is in terms of integration with other products. We have done quite a bit of work to ensure that if you're using other VMware products as well, this integrates well with it. An example for this is storage vMotion and storage DRS. So if you have today, if you have storage vMotion, if you have a VM that's being replicated and you storage vMotion at the VMDK from one data store to the other, vSphere Replication will ensure that storage vMotion also moves the transient state of replication as well. So it resumes from where it left off. And the replication is efficient from that standpoint because even though storage DRS is storage vMotioning the VMs around a data store pod, it can actually ensure that the replication is not interrupted. So you don't end up with RPO violations as well. Right. OK, so as I said, how do you actually configure this? You actually configure, excuse me. So you would actually right-click on a VM in Virtual Center. There are a set of actions that you can, say, configure replication. You actually can go in and do this on a per VM basis. You can select the RPO, whether it's 15 minutes up to 24 hours. And you actually select the destination data store per virtual disk. What you can also do is do this on a group of VMs, right? So you can actually multi-select the VMs in vCenter and go through the same configuration process as well. Of course, now you're actually setting the same settings for all the group of virtual machines that you multi-selected as well, right? So in terms of recovery, how does that work? So it's a simple 4-step recovery process. You actually, in your, either your secondary vCenter on the same vCenter when you actually want to recover, you actually right-click, select recover the virtual machine. You select the target folder, the target data store. At that point, click Finish. It actually creates this virtual machine there. If you want to go in and customize the virtual machine, you can go into the VM summary. You can say, oh, I want this VM to have a different IP address. You use the same VM configuration wizard to figure out if it needs to have a different IP address, or if you want it to have a different set of customization as well for that. So architecture. Let's spend a couple of minutes on this. So as I said, if you use vSphere Replication with SRM5, I'll acknowledge it was not that easy to set up. And that's something we've really focused on to make this very simple. As I was saying, now vSphere Replication is packaged in one single virtual appliance. Earlier we had a vSphere Application Management Server and a vSphere Application agent that you needed to deploy. Now there's only one appliance that you need to deploy. that appliance actually comes with an embedded database. So you don't need to actually deploy an additional database that you needed in the previous release. So when you actually download this appliance, you go in and actually import that into vCenter. You pair the two different vCenter servers or the two different appliances if you're using two vCenters. And once you've actually done that, you can actually go in and start replicating from side to side. In terms of deployment flexibility, as I was saying, you can actually use this with two vCenters. You can actually use it with a single vCenter server. You have the options to use it based on what your environment actually requires. We do allow you to have additional appliances as well for scale reasons. And then in terms of scale limits, we actually limit you to 500 appliances per vCenter server, right? So you have one vSphere Replication Management appliance that you deploy. That one is scale limited to 500 VMs. And once you actually start using vSphere Replication that ships with vSphere, you can, if you want to, upgrade this to have SRM on top as well. So SRM will recognize the ongoing replications that you set up and use, if you wanted to use orchestration with Site Recovery Manager. Anything you wanted to add here, Lee?
The only thing I just had, just to clear on a point there, it's 500 protected VMs of the appliance. So yeah, we just said 500 appliances. The engineers would be panicking.
Oh, I see. It's 500, yeah, protected VMs. Thank you. Thanks. So in terms of, just look at the architecture here. So you want replication between two sites. You have the source side and the target side. So in this case, you have a vCenter server on one side, a vCenter server on another side. What you would do in this case is you would deploy a vSphere Replication appliance in each side, pair it with each vCenter server, and then you can actually now configure any VMs that are running on these hosts for replication. What that does is each ESX host has an agent embedded in here that splits the traffic from the VMs, writes it to the appliance to the other side, or this is network traffic to the other side, and the VR appliance converts this network traffic to storage, right, to storage traffic. The second deployment is when you actually have a single vCenter server, and now you have, again, a single vCenter server that's managing ESX hosts in two different sites, and you want VMs that are running on this side being replicated to your central site, right? This is what is your remote office, branch office deployment. What you would do over here is configure the VMs for replication here, point them to this particular VR appliance. Again, these ESX hosts have an agent here that actually split the traffic. Network traffic goes across to the VR appliance that writes it down to the underlying storage, right? So you can recover over here. So in case you lose this site, you can recover in this site seamlessly. Want to go ahead?
Okay, thanks, Rahul.
Thanks.
So hopefully now you've got a good high-level understanding of what you're kind of going to get in 5.1, as long as you're on Essentials Plus or higher. So in my little section, I'm going to take you through a bit more detail on how replication is actually working under the covers and how we're doing this. And then we're going to revisit some of those examples that we just looked at very briefly, and I'll kind of walk you through some of the use cases and try and give you some ideas about how you could implement this when you go back to your own sites and offices. So we'll go back to those earlier examples, and I've got a few extra ones to throw in there. So one of the first things we're going to talk about is consistency, because that always comes up when we talk about replication. So what kind of consistency can we have? What do we get with this when we get to the target site? The first thing is that you have to choose an RPO for the virtual machine. We'll talk about sizing later. So you're not going to let typically the end users pick their RPOs. You're going to choose RPOs on that sliding scale that you want to offer back to the business. So you might offer them 15 minutes, 30, 60, 4 hours, whatever. You're not going to let them move the little bar around, because that would give you all sorts of headaches for capacity planning. So first thing is you pick the RPO. The second thing is, you'll see in a second, how we do this inside the kernel, using our kind of virtual write splitter, if you like. We're able to maintain write order consistency across multiple virtual disk files connected to the same VM. I'll show you in a minute how that stuff gets across to the target site, but worst case scenario, those disk images are always crash consistent, worst case scenario. And we have a mechanism in place that always ensures that we guarantee the immutability of the target disk, and I'll show you how that works. But if you're using Windows-based virtual machines, we can also, in 5.0, we allowed you to invoke VSS. so you can invoke volume copy services if you wanted to. In 5.1, we've changed the VSS integration so that we can now, if the virtual machines have them, also invoke application writers if your applications have VSS writers installed. One thing to say on that is, you get various bits of feedback from customers on VSS. We put a patch on, VSS broke, we did this, VSS broke. If VSS ever breaks or fails to quiesce the VM, we will still transfer that particular point-in-time snapshot to the target site. So worst case scenario, you're always crash consistent. We won't abort a transfer, we won't pause replication just because VSS has failed. You'll get a warning in the UI to say, at that last transfer, the VSS bit didn't work, and there's a bunch of errors, you need to go and look inside the guest, but we'll still do the change blocks from one side to the other. The second thing that we get asked a lot is, and certainly when I was down with the South African customers last week, they have remote locations that are sitting at the wrong end of very high latency, very low bandwidth connections. So they're very concerned, like a lot of customers, about how do we get that initial copy to the target site? Because even if my remote office, branch office is small, the VMs could be quite big. They could be a terabyte, 500 gig. So even if there's 10 of them, that's still a lot of data to shift across that poor link. So, and if that keeps timing out, I'm never even going to get this thing up and running. So is there another way of doing this? So we support something called preceding or physical couriering, which sounds complex and geeky, but it's basically cut and paste. You essentially do something very basic, like data store browser if you want to use that. You download the virtual disk files to a device that you can remove. You give it to somebody that you trust, or you FedEx or UPS or somebody like that. They send it to the target site. You receive it at that end, import it into a data store at that end, and put the disk files in appropriate folders. Now when you go back to the client and you right-click on the source virtual machine and say, I want to configure this one for replication, as you saw in Rahul's section, you'll get asked to choose a target folder. So you pick the folder where you've just put the disks. The disks are not going to be aligned with the source disks because they're slightly out of date, because you did that copy on Monday and it took FedEx 24 hours to get to your other site and import the disk. So you've got a 24-hour differential. But that's not a problem, because then once we have those disks, we can start to do something quite neat with them. But before you get to the neat stuff, you need to know what is doing the neat stuff. How are we doing this? There must be something inside ESX that's allowing us to do this neat stuff. And it came in 5.0, and as Rahul said, with 5.0, you couldn't use any of this stuff without SRM. And everybody who did the 5.0 beta got very excited because it looked like in 5.0 we were giving you a replication technology included with vSphere, and then everyone was really disappointed when they figured out they needed to put SRM on top to make it work. So that was a little bit of a false start, I guess, for some customers. But the thing that we built into the ESX kernel is something that we see in the bottom of the diagram there called the vScSI filter. Think of that as a virtual write splitter, and it's essentially sitting inside our virtual SCSI stack. So it sees all of the changes that the virtual machines are writing down to disk before the disks see them. Hence, we can maintain write order consistency for those disks. So when you configure replication for a virtual machine, you power on the virtual machine, every virtual disk has a connection to that virtual SCSI stack, and for every connection we have a little bitmap in memory that's backed by a state file on disk as well in case you ever lose state. And that little bitmap in memory is tracking the changes that you're writing down to the virtual machine disk file. So the second question you normally have in your heads at this point is this just change block tracking? Because it sounds the same. It's you're tracking changes and there's blocks, so it must be change block tracking. So the thing to say here is it's not change block tracking in any shape or form. Change block tracking is a completely separate piece of code. The reason it's not change block tracking from an engineering point of view is that change block tracking and how we work out differences for things like backups involves virtual machine snapshots. Virtual machine snapshots incur a performance penalty on the virtual machine when you create them. So that's okay to have that when you're doing backups, because backups typically occur once a day, late at night, early hours of the morning. But it's not the kind of framework you could use for replication, which is active all the time. So we don't use change block tracking for vSphere Replication. vSphere Replication uses the vScSI filter. The other thing we have, part of the host process, is something called the VR agent. And the VR agent is basically watching what you're doing. It does a few things other than that in terms of it does scheduling as well, but its main role is to look at what you're doing to the virtual machine. Are you adding disks, deleting disks, powering it on, powering it off, anything that might affect the state of the target machine. Its other responsibility is to also ensure, with a kind of a scheduler that we wrote, to ensure that the transfers of those little snapshots, if you want to call them snapshots, are all done in an efficient way. Because you're typically going to have more than one VM on the host. And if you've got 50 VMs sitting on the host, all with different replication schedules, it's the scheduler's job to try and figure out how to organize those throughout the day so that A, they minimize the resource impact on the host, and B, that you don't violate the RPOs as far as is humanly possible. And why do I say that? Because potentially you might have 1 or 2 RPO violations during a day or a week or a month, depending on available capacity on the WAN connection. You could have a day where the workload on the virtual machine suddenly spikes through the roof, so the virtual machine's average write rate has gone from 500 meg on average every synchronization cycle, so it suddenly jumps to a gig, which means the virtual machine might miss its RPO target on that transfer. But if you ever miss an RPO target for that particular transfer, it doesn't mean we abort the transfer. We still complete it. We just put a warning up to say, by the way, when we did that last synchronization, it took longer than average. So, when you think about RPOs, simple example, if you set a 20-minute RPO, you divide it by 2, that's 10 minutes. That means every transfer that virtual machine does needs to be able to complete in 10 minutes or less. And that sounds confusing when you first hear it, because you think, it's a 20-minute RPO, why does it need to complete in 10 minutes? But then when you think about it, it's fairly basic. If the transfer doesn't complete in 10 minutes and it completes in 11, 2 times 11 is 22, so that's a 22-minute RPO. So if you ever kind of blip over that halfway point, the system will just tell you, by the way, we missed it then, we did it in 10.5 minutes. If it then settles back down to normal workload activity for the rest of the week and month, then you don't have anything to be concerned about. If it stays at the new level forever because the virtual machine's write rate's changed, you're probably going to pick up the phone and talk to the application owner at that point and say, has something changed on your application? Have we taken on a load of new users? Is something else going on the WAN connection? Are we now oversubscribed? What is the issue? And in that situation, you only have 1 or 2 solutions. You either reset the application owner's expectation to just say, we can't hit that 15-minute RPO now that you want on our WAN connection, so maybe 30 minutes, and you come to a compromise, or you make the connection bigger, or you invest in some technology to do WAN compression. So that's what's going on inside ESX, and that component and code there doesn't exist in any previous version. Hence, you can't do this with 4.14035, and we're never ever going to backport it. So if you're hoping for that, I'm afraid that's not going to come. But when we've done our cut and paste thing, and we've kind of clicked on that target folder, that's the first time we're going to start using that filter, because it's going to respond back to us and say, those disks over there look like these disks over here. It's got the same ID and the same structure, but they're slightly different. So what I'll do is I'll read all of the blocks in these ones, and I'll tell the ESX host at that side to read those ones, and then we'll exchange the checksums. So we'll compare the differences. Then we can figure out what changed between the time that you exported them on Monday and the time it took the FedEx guy to drive in his van to the other place and import them, and then we'll just start copying the deltas across in a kind of ever-decreasing circle. And by the time we get to the end of those ever-decreasing circles, the disks will then be aligned. So in terms of the source copy and the target copy, we'll now be at a point where we can now start ongoing replication. So you can see, using that kind of crude technique of literally export-import, it provides a nice, efficient way to get your initial copies done. Absolutely, you can transfer them over the WAN if you want to, and you've got bandwidth to do that, but the key point and the key takeaway from this slide is you don't have to. The reason I've highlighted the TCP port that we use for that type of transfer is that we use 2 different ports. We use a port for WAN transfers, initial copies, what we call initial sync, and we use a different port for ongoing transfers. That allows you, if you need to be able to classify the upstream traffic and apply QoS rules if you want to do that. So once you're into the realms of ongoing daily transfers, as I said when we talked about the filter, we're essentially using bitmaps in memory to track the changes between different synchronization tasks. So every time that little scheduler determines that, you know what, it's time to do a transfer, it'll essentially take the bitmap that's got the list of changes in terms of which blocks changed since the last time, and then it'll start to transfer those blocks over to the target site. But what happens if the virtual machine tries to change a block before we've transferred it? At that point, we just take a copy of the contents of that block into a redo log file at the source site. But that is the only time we ever need to take a copy of a block, if the virtual machine tries to overwrite it before we happen to have copied it over. If the virtual machine never does that, then we just transfer the blocks. When this is active, the kind of penalty on the virtual machine is so difficult to measure that it's basically 0. So in terms of impact to the virtual machine running, the application inside it, you'll struggle to see that this thing's running. The worst case scenario for performance hit on your hosts is if you elect to do WAN transfer. If you do WAN transfer for everything, obviously you're going to see a network hit to do that. Port there at the end. You're going to get these slides. They're going to be on the Socialcast site and I think VMworld.com afterwards, so don't worry about writing everything down. You'll get these. There's nothing confidential there. But port 44046 is the port we use for the ongoing transfers. So I just wanted to give you an idea of what happens when the stuff gets to the other place, because we must do something with it at the other place. So there comes our little list of blocks, A, B, C, D, and E. They've arrived at the target site. At any point in time at the target site, we always have what you could class as your consistent disk, your gold copy, if you like. That's number 1 in the diagram there. We never write straight into that, because that would be bad. Because if we screwed it up, then the VM wouldn't be able to recover. So we don't do that. We always write the incoming transfers into what we call the current disk image. And if you ever want to see this, if you're sad like me and you want to see this stuff happening for real, you can just open up the data store browser on your target folder. You can watch. Not that it's that exciting to watch redo log files getting created and collapsed, but it whiled away a few minutes when I was doing screenshots. But we take that transfer, A, B, C, D, and E, and we write it into the redo log file, which is attached to that disk. And remember, if the virtual machine's got multiple virtual disk files, you're going to have multiple target consistent disks, each with redo logs hanging off them. So we take A, B, C, D, and E, we write it into the current disk image, number 3, and only when we acknowledge back to the source side that we've got the whole list, including E, we then collapse the current disk image into the consistent disk image, and then we've got a new time-stamped consistent disk. So that helps us guarantee the immutability of the disk. We never write straight into the target, always write into a redo log file first. And that's going on all the time, constantly happening at your target site. Because remember, the scheduler is not a fixed schedule. If you set the schedule of your RPO to 15 minutes, it doesn't mean you're going to transfer every 15 minutes. Or think about it another way. If you set the schedule to be 24 hours, we're not going to wait until 23:59 and 59 seconds and then suddenly panic because we've got 100 gigs worth of data to get across in a second. The scheduler is very intelligent, and it will look at the resource utilization on the host, and it'll try and chop up the work into little chunks. So it might do lots of transfers throughout the day for that particular VM. And it'll recompute that schedule every couple of seconds on your host. So you don't just do one transfer per day if you set a 24-hour RPO. Talked a little bit about sizing already. Minimal impact on the VMs, very small impact on the actual hosts themselves. You can, if you're using distributed virtual switches, you do get a vSphere replication traffic type. So you can throttle the traffic on the host itself. But remember, you're only throttling the traffic on that host. So you still have to then collectively add up the totals for all the other hosts to see what's going out of the actual WAN connection. If you want to try and control the port in terms of where does the traffic go, we have a kind of a tech preview feature in 5.1 that has a little tick box next to the port group to allow you to do that. Why is it tech preview? It's just down to QA reasons. So as soon as we finish QAing that, we'll fully support that. By default, how we pick the way to get out of the ESX host with the replication traffic is we look for a VM kernel adapter that's flagged for management traffic that can route to the target appliance at the DR site. If you want to control it more granularly than that, you can set static VM kernel routes if you need to. But most customers don't. They'll typically have 2 ports that can end a port group together that are the only ones that can route to the target appliance. vSphere Replication will pick those, and then it'll use those to route the traffic. Obviously, sizing for asynchronous replication is a little bit of a dark art. When we first released this or got into the beta stages, You know, I work with SRM a lot. I work with the storage vendors a lot, so I've got a lot of contacts in IBM and NetApp and EMC. So I obviously lent on them a bit and said, have you got some nice tools that I can borrow that do asynchronous replication sizing? And I got a lot of blank, empty email replies that said, what tools are these then? You know, we don't have any tools. We kind of use backup differential sizing, and we do snapshots and things like that. So this is a bit of a challenge in terms of how do you figure out what your virtual machines are doing. And we've seen various work techniques used in the field so far. You know, this stuff's not new in terms of technology. We first released vSphere Replication last year, so this is in production now for a long time. So some of the things that people do, and we've put a lot of information on blogs.vmware.com/vSphere in terms of sizing stuff that we've got from customers, so please look there. But all sorts of techniques. Some customers just configure replication. They don't declare the service as live to the business, and then they just let it run. Because there's no impact to the virtual machine, they just let it run. Why do they do that? Because in the Events tab in the virtual machine, in Virtual Center, you see all of the sizes of the transfers historically. So if you don't have any clue what your unique write rates are, and you want a way to find out, then you can just turn it on, because then it'll tell you. So if your application owner is telling you it's 25 gig a day and you don't believe him, you can just turn it on his virtual machine, replicate to the DR site. It's not a live service yet in terms of production. You can just watch it, see what it's doing. Other things that customers have done, build things like CentOS, Linux, SLES VMs, create some DD scripts, which you can get from all kinds of blogs all over the internet, and then they just generate specific unique write rate sizes. So the service providers did this extensively because they have a unique challenge in that if they're going to sell a service to you and say, you replicate to me, they haven't got a clue what your unique write rates are, and you probably don't know either, so they have to try and guess. So they essentially said, right, we'll build a bunch of VMs, and we'll have one that generates 5 gig a day, 10, 15, 25, 50, 75, 100. We'll work out what the throughput is like on our network. We'll convert bits to bytes. We'll work out how many minutes there are in a day and how many average transfer cycles there'll be. And then we can start to come up with some figures to say, for 100 gig of data per day, each transfer cycle should be about 600 meg, which should take about 6.5 minutes on our network. So they can kind of do all that on paper without even installing anything. Then they installed the stuff and found that their calculations were within 2 or 3% accurate of the figures that they'd actually worked out on paper. So they could very quickly produce a chart where it said rate of change down the left, RPOs across the top that we're going to offer, and then the sales guys talking to people like yourselves on the phone could say 100 gig, 15 minutes, let me have a look. Oh no, there's a cross in that column. The first time there's a tick is on the next one, which is 30 minutes. So we can support that across our network. So there's different ways of doing this. We are looking at, is there anything else we can do with the appliance and the code to try and give you tools to do this? So stay tuned for those. But there's a lot of good information on our blog already about examples that other customers have done to try and do sizing calculations. So I wanted to go back now and let's have a look at those use cases again in detail. We deliberately only showed you 2 very high-level slides and didn't spend too much time on them at the start because we knew that we've got these ones coming. And I wanted to cover these in a bit more detail now. So we'll start with the obvious one, which is replication between sites. How do you set that up? You've got 2 sites, you want to set that up. Those of you that have maybe had the misfortune to see me on a WebEx before or see some of my PowerPoints probably recognize some of these pictures. But for once, there's no SRM bit in here. SRM is not on those slides. You just happen to have 2 sites, and each one has a virtual center server in it, and you want to just configure replication between the 2. You've got Essentials Plus, so you can deploy the appliance, you download the OVA, as Rahul told you, and you put the OVA in each site. You obviously, now it's connected to each virtual center server, because when you deploy the appliance, you obviously register it to its local VC. And then in the client GUI for 5.1, you would then tell the appliance on the right or on the left that there's another one on the right-hand side. So you kind of connect the 2 vSphere replication appliances together. So now you can replicate virtual machines from the left-hand side to the right, and you can replicate virtual machines from the right-hand side to the left on a per virtual machine basis. I only draw it in one direction because otherwise the PowerPoint looks really confusing because then you've got lots of duplication all over the place. But essentially the virtual machine would be running on ESXi. It would go down through the filter, which we talked about earlier. So that's the little green box with the letters VRA in. Filter would do its magic, its virtual write splitting. Traffic would go across out of the VM kernel network adapters. It would hit the target appliance. and the target appliance would use network file copy service inside ESX to copy those changes down to the target disk. As you saw earlier, those changes get wrote out to the redo log files and then get collapsed into your disks. That's how it works for all the virtual machines, and that would work in the opposite direction as well. But what about some of the new use cases? What else can we do? What if you just got one virtual center server? And remember, as Rahul was saying in the example, we may have classified this as a local site replica, but that local site might not be local to you. It could be 100 miles away, 1,000 miles away. As the customers that I was working with in South Africa last week were saying that they have a use case where at each of their depots, they have a little half-height rack with a couple of ESX hosts in it, and those things run about 5 or 6 virtual machines that are critical to that depot. The challenge that they have today is that if those things go wrong, there's no IT staff there. So if those things go wrong, the way that they fix them is they either get a guy in a little Cessna plane to fly out there with a tape and restore them from the tape, or if it's close enough, he drives there, and that might take him anywhere between 12 and 13 hours, and it usually happens over a couple of days during the week. But they do have WAN connectivity to those sites. It might not be brilliant WAN connectivity, but it's enough that you could fire up a vSphere client on a virtual center server that's sitting there, and if you had a local copy of that virtual machine, you could just right-click in it and say recover, which would be a lot quicker than flying out there or driving for 13 hours. So what they're now potentially going to do is say, right, well, we can't do any SRM stuff there because we don't have 2 virtual centers, we don't want to, but we'll just deploy the appliance, we'll right-click the virtual machines, we'll select a different target data store, and we'll just have a local copy. It's not going to a different site, it's sitting in the same building, in the same rack, but now when that guy phones me up and tells me that it's application software that controls the ingoing and outgoing of petrol containers, whatever, I don't know what that's called, but when that goes wrong, if the VM won't boot or the guy's completely screwed it up, I haven't got time to argue with him on the phone and troubleshoot. I'll just say, right, give me a minute, right-click, recover, and then when I get more time during the week, I'll go back and try and unpick and do a post-mortem on what he did to try and figure out why he got into that state in the first place. But in the meantime, at least his virtual machine is now up and running, and that depot can carry on serving the petrol tankers or whatever else it's doing. But there's a little different spin on that as well. You could, if you wanted to, even replicate the virtual machine to a different folder on the same data store as the source virtual machine. I'm not saying that's the best idea in the world or the way to do it, but it'll work. So then, exactly the same, single virtual center server, single appliance, virtual machines are sitting on those 3 hosts. Those 3 hosts have the filter in and obviously network file copy. So now you can replicate from one side of the data store to the other and just have a local copy. So a very quick way, if something goes wrong in the primary, right-click, recover, there you go, you've got your copy back up and running. So what about another use case? What about branch office? And this is one of the main reasons we decided to break out vSphere Replication in this way, because this was a pain point for a lot of customers. A lot of customers that had, you imagine you've got multiple offices fairly close together, or even multiple chassis or racks in the same building that you want to be able to do some kind of replication between. But at that time, you're not necessarily that keen to go and deploy a virtual center server in each of your little offices. I was talking to a gentleman yesterday that works for a hotel chain, and in each city, they typically have 3 or 4 hotels, all belonging to the same group. And each hotel has a small environment inside it. But he doesn't want to put virtual center in 5 different hotels that are literally only miles apart. He'll put the virtual center server in the biggest hotel, and it will connect out to the other 3 or 4. So in the other sites, he's just got ESX hosts and storage. Potentially it can be local storage, because it doesn't have to be shared storage for this to work. So it could be a little kind of NAS device, or it could be a little Soho-type device, or even local disk. But what he can do now is, in the larger hotel, he's got virtual center. He deploys the appliance there. And in the periphery hotels that are on the outskirts of the city, he can now take those virtual machines and point them at data stores that are back in the main hotel. So if he needs to recover, or those virtual machines are corrupted anyway, then he can just recover them to his central machine, and obviously those hotel users have got network access into them. Or if he chooses to, he could do the other option, which is to have everything working in a single site, which was the previous use case. So you've got lots of different ways to kind of think about how you could do this. You could just keep everything central, or you might want to bring things back in towards where you are. It's your choice. You could do it that way. So what about if you want to put SRM on top of this? Because probably the third most common question I got yesterday on the booth or after we presented this for the first time is there an API attached to this that allows me to build workflows? So the short answer to that is no. And the mean response to why we did that is obviously that as you evolve your platform, we already have something that can do that for you. So if vSphere Replication, I'm just going to build out this slide and I'll talk about it in a second. vSphere Replication can do 500 protected VMs. But as you saw in Rahul's piece, when you want to recover them, you right-click on the virtual machine, select a target folder, select a resource pool, hit recover, the virtual machine powers on off that copy. Now, if that starts to get a bit dull when you've got 500 virtual machines, you might start to think about, when I first configured this, we had 10 VMs, it was fine. Now we've got 500. I don't want to right-click on 500 VMs and do four other clicks to get the VM to recover. But I've got all the replication in place now. What else can I put on top of this? So when you get into that stage, or you just see a need for more automation in the system, you want to potentially do non-disruptive tests for recovery. So your vSphere Replication, you right-click recover, it's a hard recovery, but you want to do non-disruptive testing. Or you think, now I might need to have some mechanism where I can change the IP addresses on the fly between sites, or I want to be able to embed my own kinds of scripts. Any of those use cases are then starting to put you in the realms of now I may need to take my replicated base that I built, and I now need to put Site Recovery Manager on top to provide the orchestration. So when you get to that stage, you can obviously then just take your existing replication setup, put SRM in at either site, and SRM will then provide all of the features that you're kind of familiar with for Site Recovery Manager. It will then orchestrate the moves from A to B. It provides the recovery plans. It provides the test failover capability. But the key thing is you don't have to redo any of that replication that you've already set up. SRM will just see and recognize the existing setup and allow you to start and consume it. One of the nice things that we can also do is that if you still want to maintain things like robo connectivity or local site copies for some other virtual machines and only let SRM control a subset of them, you can do that as well. So that appliance might have 100 virtual machines in its list, and you say, right, these 50, I want to build now an SRM recovery plan for those because they're now getting more critical and I need to eliminate error during recovery, and I can't afford to have anybody in the team right-clicking on these anymore. So I let SRM control those ones. But the other 50 here, they're just the robo ones. I don't care about those. So they can just stay as they are. You don't need to give everything over to Site Recovery Manager's control. And when you deploy SRM, the diagram doesn't look that much different. You don't redo any of your configuration. You simply just add in the SRM servers, which are the kind of the blue boxes there. They connect to the appliances that you've already deployed, and then they consume those virtual machine replication tasks. But you do have to, as per the diagram there, have to have a second virtual center server at the opposite site where you're replicating to. Because obviously part of the design criteria for Site Recovery Manager is that there's no single points of failure. So we have to have a management framework at the target site because we can't rely on anything on the left-hand side to survive, to be destroyed. So SRM will require an additional virtual center server. But you can kind of migrate into that as and when you need to. So to summarize what hopefully you've learned today, vSphere Replication, a lot of hands went up when Rahul said, who's got Essentials Plus? So the good news is, once we put the bits on the website, and I can't give you the date for that, so don't ask me, but it's not too far away. If you're on Essentials Plus, everything you see in the slides today, you can go and do and test back at your own offices. No additional charge for that. It's part of the vSphere platform now. Asynchronous replication, left to right, robo use case, local virtual center use case, and as and when you need to, if you want to put SRM on top to provide more sophisticated DR capabilities, you can do that as well. So with that, if there are any questions, either feel free to come up to the front and ask us, or we'll wait outside. But hopefully that was a useful session, and I thank you very much for your attendance at such an early time in the morning. And you will get these slides on Socialcast and VMworld.com afterwards. So thank you very much.